This lecture video pertains to proportion intervals for true population proportion. If you notice, the title says Z intervals also. A proportion interval for true population proportion, rho or P, is a type of Z interval. So we will be using the two-page Z table once again, which is good news. The properties of the standard normal distribution in Z will apply to this type of confidence interval, even though it's about population proportion rho or P. It is still a type of Z interval using the two-page Z table. We first need to talk about the formula. P hat is sample proportion. Remember, it is the best point estimate for a true population proportion P or rho. P hat is the point estimate or statistic, and rho or P is the parameter population proportion. Remember, point estimates are good, but confidence intervals are better. P hat is pronounced as I pronounce it, but you type it or you spell it as P dash hat. It has a formula associated X divided by N. Here's an example. In a sample of 50 students, 30 students received the flu shot. Therefore, the proportion of students receiving the flu shot from my sample of 50 students is 60%. 30 out of 50, decimal is 0.6, percentage is 60%. It reads, in a sample of 50 students, 60% of them received the flu shot. Now Q hat in the formula. P hat plus Q hat will give us 1 or 100%. In the example above, if P hat is 60%, Q hat must be 40%. Together, 60 and 40 will give us 100%. P hat, in terms of the characteristic of receiving a flu shot, is 60%. Q hat is the percentage of students that do not receive the flu shot, 40%. Those are opposites to each other. P hat, they receive the flu shot. Q hat, those that do not receive the flu shot. It is very important to understand that when you calculate a proportion interval for true population proportion, and you understand that P hat is your sample proportion, that the confidence interval is all about using P hat. Your desired characteristic in this case is having a flu shot. This confidence interval is not about those that did not have the flu shot, which would be our undesired characteristic, not receiving the flu shot. So this confidence interval is all about those that receive the flu shot in terms of P hat, which is the best point estimate for true population proportion rho or P, and that's 60% for this sample. Margin of error formula is now different. It is Z times the square root, and under the square root is this quotient P hat times Q hat divided by N. It is the square root of the entire quotient. Once again, you will round E, the margin of error, to 4 places accurately. The definition for E is now the following. The margin of error for this type of confidence interval, it is the maximum difference allowed between the point estimate p hat and the true population proportion rho or p. The point estimate and the true population parameter. We may never know the true population proportion. That's why we're trying to find a confidence interval for true population proportion. We do know p hat. Whatever p hat is, and even though p is unknown, the maximum difference allowed between them is E, the margin of error. And that is going to be based upon your given degree of confidence, which determines your critical value. And of course, it's going to be dependent upon your sample proportion p hat and your sample size n. But E is the difference, the maximum difference allowed between the point estimate, which we know, and the true population proportion, which we may never know. Once again, the critical values for a 90, 95, 98, and 99 confidence interval for the true population proportion this time are the same. For 90, it's 1.65. For 95, it's 1.96. For 98, 2.33. And for 99%, it's 2.58. This means that I have the right as your teacher to ask you to find the 96% confidence interval for the true population proportion rho. Even though it's not one of the four famous ones, I can ask you for 96%, 94%, 92%. Remember, when it's a t interval for the mean t interval, I can only ask you 80, 90, 95, 98, 99. When it's a t interval for the true mean, now that we're talking about proportion intervals for true population proportions, and these are still z intervals, but it's for true population proportion, I can go back to asking you for those that are not in the list. The same procedure applies. You would draw your z-axis, bell-shaped curve, shade the middle 96%, and you would see that 1 minus 96% is equal to 4%. We have 4% left over. Each tail would be half of that. So each tail would have to be 2% in terms of area. So 0.02, 0.02, and we can use those areas to find our cutoffs, plus and minus z. You can now go back to your 2-page z-table and look up an area of 2% and work to the outside to get your negative z-score. Or you could do invert norm on the bottom 2%. I will do invert norm first. Second, remember that distribution button? Arrow down to invert norm, enter. That's the area in the left tail with 96% degree of confidence. Negative 2.05. You know, and I know, that even though it says negative 2.05, which goes here now that we know that z-score, this one has to be a positive 2.05. Therefore, the critical value is positive 2.05. Even though this is a proportion interval for true population proportion, for a 96% proportion interval, the z-score is 2.05. If you wanted to look up that 2% in the 2-page Z table, you're looking inside the table and you're trying to find the area closest to 2%. Okay, here. There's the area closest to 2%. Remember, these areas in the Z-table give you area below an unknown Z-score. And when you work your way to the outside and up, and we also used invert norm on this 2%, area below the cutoff, you get negative 2.0 and up 0.05. Together, that Z-score is negative 2.05. When we went with the closest to 2% here. The critical value is positive, however. Now, next page. The next page is actually going to be an example, a complete example of our first proportion interval for true population proportion. It gives you all the details, it gives you all of the steps, and it also shows you the commands that you put into the TI-8384 calculator. Here we go. Highlighter time. Suppose that 40 people were checked for anthrax exposure, and the results stated the following. 12 people were exposed, and therefore 28 people were not exposed. Find the 95% confidence interval for the true proportion of people who have been told that they have been exposed to anthrax. So this confidence interval is all about those that have been exposed. It is not about those 28 people that were not exposed. If you notice with the template, which you could take your same basic template and start filling it in. It says 40 people were checked for anthrax exposure, and the results stated the following. X equals 12 people were exposed, and 28 people were not exposed. I'm not going to write down the number 28 because this problem is about being exposed. Find the 95% confidence interval for, and this is where you determine your parameter, true proportion row. That's very important. It does not say true mean, but true proportion, who have been told that they have been exposed. So this is about those people exposed. Now, since this is a type of Z interval, and we want to be 95% confident, we've memorized that that is a Z-score or critical value of 1.96. Margin of error. E is equal to, if you go back to your formula page, you have p hat minus z times the square root of p hat times q hat over n, and then p hat plus z times the square root of p hat times q hat over n. So E is that number that you subtract, and it's the same number you add. For this problem, to determine p hat, they gave us the information that we needed so that we could plug into our formula for p hat, and that is 12 divided by 40. The textbook says if that is not a nice decimal, which this is a nice decimal. It turns out to be exactly 30%. But in the future, when you are calculating p hat and it's a repeating decimal or a non-terminating decimal, the textbook says, rounding rule, you are allowed to use a p hat that is rounded accurately to 3 decimal places. But that's only when you have a p hat that has a repeating decimal or a non-terminating decimal. It's nice when they are exact like this one. I'm going to put an implication arrow here. This implies that Q hat is 1 minus P hat, or 1 minus 30%, which gives us 70%. And you know, that 70%, that percentage is the number of people in the sample of 40 that were not exposed to the anthrax. That's that 28 people. 28 out of 40 would give you 70%. Those people were not exposed. This confidence interval is all about those that were exposed, so we're going to go with the p hat of 30%, where they were exposed. Q hat, 70% were not exposed. So we plug into our formula. And again, if you have to round, you will round to 4 places accurately. I am going to show you my method of plugging into the calculator for those of you that may need this. I'm going to clear out my window first. One way to attack this formula is to say 0.3 times 0.7 divided by 40. If you notice, that number is what I've calculated under the radical before I take the square root, 0.00525. Now I'm going to take the square root of that number. I do second square root of second answer because I don't want to retype that number. Enter. This number is the square root of p hat times q hat divided by n. So the last thing I would need to multiply by is the critical value, 1.96. The E, or margin of error, is 0.1420 if you round accurately to 4 places. So I'm going to put that in my calculation. And we did need to round to 4 places accurately. Now I'm going to show you how to put the formula in the calculator in a more direct way. In other words, just like the formula says, I will show you how to put it in. 1.96 times the square root, and this is where it's important. Some older calculators will present you with or prompt you with parentheses. This is the new TI 84 Plus C Silver Edition. You don't need parentheses, but I like to do this. Parentheses 0.3 times 0.7 and close it up because that's my numerator. Notice how I'm still under the radical with my newest TI 84 Plus C Silver Edition. Make sure that you are dividing by n under the square root. Now with the new calculator, this cursor is saying, are you done under the radical, or do you want to arrow or exit out from underneath the radical? And then I press enter. 0.1420 rounded accurately. For those of you that may need the OTI 83, I will show you what you would need to do to plug this in exactly in a more direct way. It's crazy how they differ. When you say 1.96 times the square root, you are prompted with that set of parentheses. So this is what I do. I would say another set of parentheses, and I would say 0.3 times 0.7 and close that. Then divide by 40 and then close the second set of parentheses. That second outermost set of parentheses under the radical tells us that we are calculating p hat times q hat divided by n, and we're taking the square root of the entire quotient, p hat times q hat divided by n. So with the old TI-83, I used two sets of parentheses. 0.1420. Don't give up. Practice using your calculator to find E. And unless you get this number, you don't know how to use your calculator to find E with the p hat and the q hat and the critical value 1.96. Practice is very important. Going back to the formula, p hat minus z sub c square root of p hat q hat divided by n less than rho less than p hat plus z sub c square root of p hat times q hat divided by n. But I'm not going to use that formula now that I know E. I'm going to work with p hat minus E and p hat plus E. Going back and remembering that p hat is 0.30, and now using my E of 0.1420, and then p hat is 0.30 plus my E of 0.1420, I can find my lower and my upper. 0.3 minus 0.1420 is 0.158. And then when we add 0.3 plus my E, 0.1420, you get your upper of 0.442. Rounding rule. Going to the rounding rule page, according to your textbook, for proportion intervals number 6, for those types of confidence intervals, it says round the lower and upper values to 3 decimal places accurately if you have to round. In the problem that we just worked together, no rounding is necessary because we have those numbers already given to 3 decimal places. So your final answer will be, for this problem, 95% of those being exposed, 95% degree of confidence. Another way to write it, since it is proportion, is 15.8%. 44.2%. We are 95% confident that the true population proportion of people everywhere exposed to anthrax is between 15.8% and 44.2%. The confidence interval width, if you use the decimals, 0.442 minus 0.158, you receive a difference of 0.284. If you wanted to change that to percentage, you could say the width is 28.4%. And there's your first problem dealing with proportion intervals. Again, it's a Z interval. Very easy, especially since it's still a type of Z interval. Going back to your lecture packet, if you notice, I basically just went over how we received the final answer for E, and for our lower limit and for our upper limit, and then our percentage answer. I did not list the confidence interval width there, so we did that here. 28.4% is the difference there, or 0.284. But that's something you can list on your sheet, the width. Now the calculator, I'll show you how to use the TI-8483 calculator, and I will show you where you need to go to put in the information. You will clear out your window. That's always best. Go to Stat, arrow over to Test, and you do not see at first glance, unless you scroll down, proportion interval. There it is at A, alpha A. So you'll have to scroll down to see it. 1 prop Z interval. Prop means proportion, and it's a type of Z interval. Notice how very little information they ask you. They ask you for the X, those people exposed, out of the sample size, and the degree of confidence. And it said that in this particular problem, that 12 out of 40 people were exposed. And the degree of confidence, 95%. And then calculate. And then enter. The lower number when you round to 3 places is 1.158, and the upper number when you round to 3 places is 0.442. So once you round to 3 places accurately, 0.158 and 0.442, it agrees with what we got by hand. So very simple. Stat, arrow over to Test. Go on down, and it's alpha A for 1 prop Z interval. Very, very simple conclusion. And again, this output that you see means that your confidence interval, 0.158, less than rho, less than 0.442. Once you round, and that's exactly what we got by hand. The rest of the lecture packet includes some problems. Well, for example, this problem is more or less a raw data problem, where you have your sample and it says suppose 40 people were checked for anthrax exposure, and the results are as stated above. Find the 92% confidence interval for the true proportion of people who have been told that they have been exposed to anthrax. And then turn around and say, find the 96% confidence interval for the true proportion of people who have been told that they have not been exposed to anthrax. So this problem focuses on being exposed with these yeses that you see. This problem focuses on those that have not been exposed with the word no that you see. And this is 40 different people and the results of their test. Yes, exposed. No, not exposed. That means the p-hat for each problem is going to be different. This one is all about exposure. This one is about those that are not exposed. Notice how I ask you to find the 92% and the 96%. Those are not one of the, the famous 4, 90, 95, 98, and 99. We worked a problem just a moment ago dealing with the 96% and how we discovered that it was a critical value of 2.05. We did that here as an introduction in this video. So if you have a 96% degree of confidence for a proportion interval for true population proportion, the critical value is 2.05. Therefore, I thought in this video we could just do this one together. And that will be the conclusion of the video. Try the first one on your own, the 92% people that have been exposed. So here we go. We're doing this problem, 96% confidence interval for the true proportion of people who have been told that they have not been exposed to anthrax. Well, we know N is 40. X is equal to, and in parentheses, I'm going to put not exposed. That means I have to count up the number of no's that I see above. So what I think we should do is check them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. X is 32. As you can imagine, if you were to count up the people exposed, 8 people were exposed. 1, 2, 3, 4, 5, 6, 7, 8. So for this problem, number 1, all of those exposed, N is 40, but X is 8. And we're not doing that problem. But when you go to do that problem, exposure, X is 8. P hat is going to be 8 out of 40 exposed. 8 divided by 40, P hat. Here, our P hat, sample proportion, those not exposed, 32 out of 40. And obviously, it's nice to change that to a decimal to see what you're actually dealing with in terms of a percentage. And that is 80% exactly. As you can imagine, here, P hat, X over N, or 8 over 40, that P hat is going to be 20%. Again, we're not doing that problem. Not exposed, 80%. P hat. Exposed, 20%. 8 out of 40. How do I know that? If 80% or 32 out of 40 have not been exposed, then 8 out of 40 have been exposed, and 8 out of 40 is 20%. 20 plus 80 is 100% of my sample. That includes everybody sampled and tested. 100% of the people tested. Now we're ready for our template. So that we can finish this problem. Again, I just want to focus on this example. Number 2, 32 people were exposed. No, excuse me, not exposed. And then therefore P hat is 32 out of 40, which is 0.80 or 80%. And we have to find the 96% confidence interval for the true proportion, which is rho. That is our parameter of interest, rho. Here we go. Critical value. We went over that at the beginning of the video, so I'm just going to say 2.05. And again, that is based on 96% degree of confidence. refer to the beginning of the video. Margin of error, Z sub C Z sub C, square root of P hat times Q hat divided by N. 2.05 square root of 0.80, which is our P hat, those not exposed, times Q hat. We didn't talk about Q hat above, but Q hat is 1 minus P hat, which is 1 minus 80% or 20%. Together they add up to be 1 or 100%, and N is 40. Remember, divided by 40 is also under the square root. So I'm going to plug it in directly to the calculator, and that is 2.05 times the square root of 0.8 times 0.2 divided by 40, and arrow out from underneath the radical. Enter. 0.12965 is 0.1297 is what we're going to use for our E, margin of error. I'm going to put that here. Remember, that's the maximum difference allowed between the point estimate P hat of 80% and the true population proportion P, which we don't know. That's where we're finding its confidence interval, margin of error. Formula, P hat minus Z sub C, square root of P hat Q hat divided by N, less than rho, less than P hat plus Z sub C, square root of P hat Q hat divided by N. But the formula that I use in terms of working the problem is P hat minus E and then P hat plus E. P hat is 80% minus the E of 0.1297 and then 80% plus E of 0.1297. When you subtract E, you receive 0.6703. When you add E, you receive 0.9297. Looks like we're going to have to round here according to the rounding rule, which says to round to 3 decimal places accurately. The final answer for the lower and the upper. And I'm going to put the 96% here. When we round, 0.670 less than rho, less than P, which is less than, oh, this is a good one, 0.9297. So we're rounding to 3 places accurately. This 7 rounds this 9 to a 10. So to 3 decimal places accurately, it should be 0.930 because of this 7. Rounds this to a 10, which essentially rounds the 29 to 30. I, again, expressed it to 3 decimal places. You could also say that this is roughly between 67.0% and 93.0%. If you wanted to change it to percentage. The confidence interval width is going to be equal to 0.930 minus 0.670. And that is 0.26 difference. You could add a 0 there if you wish, because they're given to 3 places. So a 26% difference between that is your confidence interval width. Now, calculator, to verify this problem about those that were not exposed, you would go to stat and arrow over to test, scroll down or arrow down till you see alpha and press enter on one prop Z interval. We had 32 people not exposed out of 40, and it was a 96% degree of confidence. 32 out of 40. Enter. Rounded to 3 places, 0.670, 0.930, which is what we got by hand once you round accurately to 3 places. So there you go. There's the question, and there's the answer to the problem concerning those people not exposed. We are 96% confident that the true population proportion of those people not exposed to anthrax is between 0.670 and 0.930. I feel confident that you would be able to do this problem on your own. I also now feel completely confident. I hope I'm correct, that you would be able to do this 5-problem review packet. We will talk about these in general if you have questions, but this is like a review of Z intervals for the true mean, T intervals for the true mean, and proportion Z intervals for true population proportion. I thought that it would be a good idea to have a review of these types of confidence intervals before we did the last and final confidence interval called those chi-square intervals for true population variance and true population standard deviation. It's going to introduce a whole new distribution called a chi-square distribution and a chi-square table. Try these on your own. These 5 will either be a Z interval for the true mean, a T interval for the true mean, or a proportion Z interval for true population proportion. You have the knowledge, you have the skills, you have the formulas to work with these 5 problems. Again, we can talk about these in class, give you the answers if you wish, but the last lecture is that lecture pertaining to confidence intervals for true population variance and true population standard deviation. And that would conclude the information that will be on your test, and that would be test number 3, confidence intervals. And that would be that we, in this class, we have covered the Z interval, we have covered the T, and we have covered the proportion. One remaining. Thank you again for watching the video. I hope you were able to learn the material that you need to learn pertaining to the proportion intervals for true population proportion. Again, we can address any questions or any confusion that you may have in class once we meet